Hello guys, how are you? Okay, welcome back to my channel Vigyan Jyoti. So now we are going to the depth of the current electricity. So far we have come across the various topics like first of all the basics of the atom, the structure of atom, then the flow of electrons, then charge, what is potential difference, and then lastly we have done we have done current, right? So the different factors that we have covered is the potential difference or potential, then the current, then who is responsible for the flow of current, right? Then we have also covered up what is the direction of the current, what is the direction of the electron, what is it actually. So everything we have we have covered up, right? Now the very important topic of electricity that we are going to proceed with is the resistance, okay? So before understanding what is resistance, we need to pay a tribute to this man, or let us introduce ourselves to this man. Okay, so this is Sir Ohm. Okay, so we are quite famous with this law, that is Ohm's law. It's not Ohm, it's Ohm. The H is silent. Okay, so let's see what is the law about. But before the law about, he has asked us or ourselves to see this experiment. Okay, he has asked us to see the observation that he has done while doing this experiment. So what he has done is, he was basically trying to compare two physical quantities. What are those physical quantities? So first physical quantity that they want to compare is, wait just a second. So the first physical quantity that they have, the two physical quantities that he has tried to compare is current and voltage, okay? So I and V, okay? So these are the two things that he has observed, that this was a setup, okay? So this is what? A battery or a cell, right? This is a battery, okay? Fine, not a problem. This is a switch. Now my question is, out here, the switch is on or off? The switch is off, right? Why? Because it's not connected. It is not closed, right? It is not closed. Okay, first let us see what are the parts of each and every circuit. Okay, so this is the battery, this is the switch, and here is the bulb, the electrical appliance that we want to use. Okay, this is a rheostat as discussed, okay? And this is my ammeter, and this is my voltmeter. Okay, so fine. So what is the function of ammeter? We have discussed it, that the function of ammeter is to measure the current, and voltmeter, the function of the voltmeter is to calculate what is the potential difference across any 2 points given. Okay, so we have, in this case, the potential difference between this point and this point has been calculated by the voltmeter. Okay, rheostat we have already discussed. This is a type of variable resistance that we can offer it to the flow of electrons. Okay, so this is resistor is something fixed and rheostat is variable, like we can adjust according how much we need and all, we can adjust the resistance. Okay, now he has tried keeping all other things constant, like the temperature, the material of the conductor, the type, everything was fixed. Now what he has tried to compare is the voltage and the current. So he has found that as he was increasing the voltage, that is 0.85, so we can say this is increasing, right? It's increasing. So when he saw that he was increasing this voltage like 0.85, 1.7, 3.5, 5.0, 6.8, it was seen that the current was also increasing. Okay, he found out that as my voltage is increasing, my current is also increasing. That's what he has found out. Okay, that means as my voltage is increasing, my current is also increasing under the condition where all other factors and parameters are kept constant. This is what he has observed. Now definitely the switch needs to be closed. The switch needs to be closed. Then only the circuit will be complete and the current will flow. And adjusting the voltage, when he has tried to adjust the voltage, he found out that as he was increasing the voltage, the current was also being increased. Now we shall come at what was the law. So German physicist Georg Simon Ohm states that at constant temperature, okay, the current flowing through a conductor is directly proportional to the potential difference across its ends. So now in this case, who is depending? Definitely the current. So the first one who came into the picture was potential, right? So who is depending on the potential? Current. So it was told here that I is directly proportional to voltage. Okay, I is directly proportional to the voltage or the potential difference. So in a way we can say this also, because if you see that current is increasing, then definitely the voltage has been increased, keeping other factors constant. So this is what he told about the, the proportionality dependence. Okay, that is what he told. That is, if something is increasing, if V is increasing, I will also increase, and if V is decreasing, I will also decrease. So this is something, it's okay, understood. Now we shall go to a numerical example. Okay, so the same experiment that he has done, that is the same value we have taken. So current and voltage he has found out, this is something. Okay, now what he tried to do is, he tried to find out the ratio. Okay, so first case, so there are how many total? 1, 2, 3, 4, 5. So total there are 5 cases. Okay, so first of all, case 1. Okay, so case 1, what he tried to do is, since V is directly, okay, sorry, I'll just explain it once. Sorry. Yeah. So what he did is, V is directly proportional to I, right? This is something that is explained. Ohm's law states that the potential difference, or you can say the current, is directly proportional to the potential difference applied across its end. Okay. Now, when we remove this proportionality sign, we get one constant. Okay. So now what he did is, he tried to find out this constant. He tried to find out what? This constant. Okay. So we will find out what is this constant. Okay. Let's see. So how will you find the constant? That means we will find the ratio between voltage to current. Okay. So first case is voltage to current, that is 0.85 and 0.05. So we can write here as 85 by 5. So what I'll do is 85 by 5. 5 ones are 5. 5 ones are 5, 5, 7. So how much it is coming? The constant? 17. Okay. So let's see for the second case. 1.70 divided by 0.10. So again the same story, decimal points, both are then, so 100 gets cancelled. So we can write here 170 by 10. So how much we got? That means, okay, fine. That means in case 1 and case 2, the constant is same, right? Okay, then case 3, let's see. Okay, how much it is? 3.5 by 0.20. Now in this case, it will be 100 because I'm eliminating this decimal point, and in this case, I'm eliminating this decimal point, so it will be down 10. So 3,500 divided by, okay, so 2 zeros will be cut, and it will be 17.5. So what is the answer? 17.5. That was almost same, right? Okay. Next, case 4. Case 4. Case 4 says what? Voltage is how much? 5. And this is 0.3. 0.3, right? 0.3, yeah. That doesn't factor, right? 0.3 and 0.30 is same. So again, I'll do here 10. So 50 divided by 3. Okay. So 3 ones are 3, 20, then 3, 6 are 18, 2.06 again. So it will be going 6, 6. That means we can round it off and we can make it as 17. So here also it's almost the same, right? So the last case, I suppose, the last case, that is case 5. Now in case 5, what is happening? Okay. Now in case 5, what is happening? 6.8 divided by 0.4. That means we can write as 68 by 4. Now we can again divide it. 4 ones are 4, 2, 28, right? So that means, so if I make a box, or I may suppose, let's say, no, I have to do it here itself. Okay. So the first case, that means in the first case, it's 17, right? Okay, I just need to make one space. I'll just copy here one case 1, okay? Because I want this row. Case 1, I want to copy it. That means you're getting how much? Case value you're getting as 17. And case 5, how much you're getting? There also you're getting 17. Okay, I'll just delete this part so that I can make another row here. Okay. I'll just make another row stating it is the constant. Okay, stating that this is the constant. That is which constant? K. Okay, so let me make one other column, row. Okay. Okay, so what is the constant value that we have got for case 1? 17. Case 2, 17. Case 3, 17.5. Case 4, 16.66 rounded off to 17. And case 5, we got pure 17, right? So that means we saw that there was something that was kept constant in, finding the ratio, that is my constant. Now he has further, termed this K as to be what? Yes, resistance. That means the physical quantity, that means from this constant he has given birth to another physical quantity. Actually, he has not, the concept was there from previous, but he has identified. So what is the physical property? Next physical property of the material, that is resistance. Now we will come to the topic as resistance. So I think till this much it's clear, Ohm's law. So Sir Ohm told this, that the potential difference and the current, they have a relation. If we increase the potential difference across the two ends, the current is definitely going to increase. Now, what is that constant between these two factors or those two parameters, which was all the while all throughout the circuit or throughout the experiment was same? It was the resistance. So this is how we found out. Okay, now we will come to the topic as resistance. Thank you guys for watching this video. If you really find these videos informative and helpful, please do subscribe my channel Vigyan Jyoti. Hit the like button and share it with your dear and near ones. And yes, please don't forget to comment because your feedback does matter.